Welcome to the lesson, Volume with Aunt Jane, Part 2. This lesson will continue the idea of using our imagination to break up a shape and put it back together to form a box. Once we have a box, we can calculate its volume by multiplying the width, height, and depth. In the first part, the depth of this box was 1, and so all the cubes could be seen and actually counted. In this second part, on the other hand, it's more of a genuine 3D question. The depth of the boxes is more than 1, and so not all the cubes are visible. We continue where the last lesson left off. Ruth and John typed 195 into the keypad and entered their Aunt Jane's house. They saw a message on the wall. We are creating structures made of cubes, and the length of their side is 1 cube, so this is 1 cubic unit. The volume of the structure is the number of such cubes. For example, the volume of the structure is 5 cube units. In this way, we connect the concepts of a volume and cubic units. In these questions, all the structures are made of cubic units. This makes it pretty straightforward. For this lesson, we assume the students know how to calculate the volume of a box. This is just a reminder. We continue the story. Next to the message was a drawing. This drawing is a very convenient way to conceptualize the calculation of the volume of a box. This is what we want the students to understand and practice. The box is divided into layers, so we can calculate the number of cubes in each layer. 3 times 2 is 6. We then multiply by the number of layers, which is 4. So the formal calculation looks as follows: 3 times 2 times 4. In this lesson, as in all lessons in IC Math, the goal is not simply to give a formula that the students have to remember, but a formula that is connected to their intuition. In this case, a visualization is very effective. And we continue to the first question of the lesson. Suddenly, Ruth and John saw a big structure in the corner of the room. They understood that their task was to find its volume and type it into the next door keypad. What is this volume? That is, the number of cubes. Give all the students some time to think, even if some raise their hands immediately. Now, there are different ways to think about this problem. The students could think about this part separately and first calculate the volume of the box, 4 by 3 by 4, and then add these. Or the cubes may be separated into layers, maybe like this. Then this cube could be imagined to move here. And so we have 4 times 5, which is 20, and then we multiply by 3. It's interesting to see what methods will come up in your class. It could be an insightful experience for the students to see how other students think about the same problem in a different way than them. The technique we want to focus on here and hope one of the students does is as follows: to move these 3 cubes over here. Let's do this with the app. In class, you can also use the app or simply move on to the next page where the solution is ready. Let's go to Erase Cube and erase 1, 2, 3. And then to Add Cube and add 1, 2, 3. We can click a long click on the scribble button to erase the scribbles. If we want, we can mark the cubes that we transferred. We click Mark Face Mode and color them. Students may offer different ways of calculating the volume of the box at this stage, but one way we want to make sure to offer is to separate the shape into layers. Let's click here and click on the structure. Now, it's easier to see that each layer has 4 times 3 cubes, which is 12. And there are 5 layers, so we have 12 times 5, 60. And as we said, we can find this formal solution on the next page. And now we move on to practice. We have a continuation of the story that introduces 5 more structures similar to the example we saw. Let's see them in the student worksheet. The task of the students is to calculate their volume. They can use a similar technique to the one we saw, though there is sometimes more than one convenient way to do the calculation. See that the students understand that they have the freedom to decide how to approach each structure. After the students finish and write the sum of the volume down here, which is the code, we continue to the app to review their solutions. And we're back in the app. One of our goals is to promote flexible thinking, so try to find the different ways in which students solve this question. For example, the layers can be separated to the right, and we have something like this. Now we could do the calculation of 9 plus 8 plus 7 plus 3. Let's reset this. Besides all sorts of various methods, this lesson does focus on the idea of reordering the cubes to create a box. In this case, we can remove these 3 cubes from here, 1, 2, 3, and place them over here, 1, 2, 3. And now we have a 3 by 3 by 3 cube. We can see the solution on the next page. And here it is. We see how these 3 cubes are moved here. We continue to question number 2. Again, let the students give their answers. What we hope they see is that these 2 cubes can be moved here, and these 4 cubes can be moved here. We get this solution, a 4 by 4 by 2 structure, and the volume is 32 cubic units. We continue to the third question. In this question, there is a surprising number of elegant solutions. It will be interesting to see which of them the students come up with. One solution is to separate these 2 structures in our imagination, and we get one box, which is 4 by 4 by 2, and one box, which is 2 by 2 by 4, and we add their volumes to get 48. Now, let's see another way of looking at it. If the students don't see it, you can give a hint and say that these 2 boxes can be combined to form one box. And here it is. One box of 6 by 4 by 2. Surprisingly enough, there is another elegant way to find out the volume of the structure. This solution looks like this. These 3 levels of 2 by 2 are spread out over here, so we get the box 4 by 4 by 3. Again, the goal is not simply to solve the problem, but to promote flexible thinking as we do so. Let's move on to the last question. Here there are especially interesting ways of solving this problem. Let the students provide their ideas. On the next pages are the solutions we came up with. Here, this wall is cut up to 2 layers of 2 by 3 and added to the rest of the structure. In another solution, this top layer is cut off and used to fill up the box like this. A third solution involves a very different way of looking at the problem. Let's see it. We first add an imaginary box of 3 times 2 times 2 to get a box with the area of 48. Then we remove the box that we added. It will be interesting to see how many students reach this way of thinking about the problem. Let's finish the story. Ruth and John typed 143 into the keypad. As you remember, this was the sum of the cubes in the 5 structures in the worksheet, and entered the room where they met their beloved aunt. Let's conclude what we learned. We will state this in general terms. We practiced using our imagination to make a question easier to calculate. In this case, it was connected to calculating the volume of a structure, but as we understand, the same idea can be used for a wide variety of applications. Our goal here is not only that the students to practice calculating volumes of structures, but that they develop their flexible thinking skills. And that's it. We hope you enjoy this lesson in class. Thanks for watching.